Algebra 1 Final Review Part 3 of the packet. Question 1. A school plans to have a fundraiser before basketball games selling shirts with their school logo. The school contacted two companies to find out how much it would cost to have their shirts made. Company A charges a $50 setup fee. So the setup fee would be the cost for them just coming to the school, and that would be your y-intercept, and $5 per shirt. Since the word per is there, 5 would be the slope, or the rate of change. And then they also describe Company B charging a $25 setup fee, which is the y-intercept, and $6 per shirt, which is going to be the slope. Write an equation for Company A that could be used to determine the total cost A when X shirts are ordered. So A is going to be equal to, Company A is $50 setup fee and $5 per shirt. So we have to take 5 and multiply by the number of shirts, which is X, 5X. And then you add on the y-intercept, which is the setup fee. Company B also needs an equation, so write a second equation for Company B that could be used to determine the total cost B when X shirts are ordered. Company B had different amounts. It was a $25 setup fee and $6 per shirt. So 6 is your slope there, 6 times the number of shirts, X, and then you have to add on the y-intercept, which is the setup fee, $25. In the third part, Part C, they want us to determine the number of shirts in which both costs of A and B are equal, meaning that we have to set those two equations equal to each other and solve for X. So Company A's equation, 5X plus 50, has to be set equal to Company B's equation, which is 6X plus 25. We want to move all our variable terms to the left-hand side. In order to do this, we're going to take the 6X and subtract it from both sides. This is going to leave you with negative 1x plus 50 equals, those cancel out, 25. And you want to move the constants to the other side. So the positive 50 is going to be taken off of that left side by inverse operations, subtract 50 from both sides. And now you have a negative 1x equals 25, this cancels, equals 25 minus 50 is negative 25. And if we want to know what x is equal to, we have to divide by negative 1 on both sides. So x is going to be equal to negative 25 divided by negative 1, which is 25. That's how many shirts in which both companies would cost the same amount of money. Question 2. Alex launched the ball into the air. The height of the ball is the output. It could be represented by the equation h is equal to negative 8 times t squared plus 40 times t plus 5, where h is the height in units and t is the time in seconds after the ball was launched. We want to graph this between t is equal to 0 and t is equal to 5. So our time is the input, the x-axis here. So we want to go from 0 to 5. So we have plenty of space to dedicate 2 boxes for each second. So right here would be 1 full second, half a second, and then 1 full second, 1.5 seconds, and then 2 full seconds, 2.5 seconds, and then 3 seconds, 3.5 seconds, and then 4 full seconds, 4.5 seconds, and then this would be 5 full seconds. We're not sure how we want to label the height yet until we find out what values we're working with. We're going to utilize our graphing calculator to help us. We have our inputs t, and then we have our outputs h. And we're going to use our calculator. We're going to go to y equals, and we're going to plug in the equation given. Negative 8. Instead of t squared, we're going to put x squared. X can be used as the input. Plus 40t, 40x, plus 5. And then you want to go and find out your table of values that you're working with using second graph. So we could see that at 0 seconds, the ball is 5 units in the air. 1 second later, the ball is 37 feet in the air. 2 seconds later, the ball is 53 feet in the air. 3 seconds later, the ball is still at that same height of 53 seconds. 4 seconds later, the ball is back to 37 feet. And 5 seconds is where we're asked to stop our interval. It's back to 5 units in the air. The units could be yards, it could be feet. They don't really specify in this question. So we're dealing with output values ranging from 5 to 53. So I'm going to choose to count, and I have 20 boxes here. So my highest value is around 60, if we round that up. So I'm going to go by threes. I'm going to let each box represent 3. And I'm going to label that. Depending on your equation, you might want to use different, and your amounts, your outputs, you want to use different scales, but this is perfect for this one. 15 units, this is 18 units, 21, 24, 27, 30 units, 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60, which is 20 boxes, so 20 times 30. And now we're going to graph these, and we're going to have to round a little bit. So we have 0 seconds, which is right here, and you're 5 feet in the air. So we're not going to go on 6, but a little bit beneath it. 0 seconds, 5 units in the air. We're going to go a little beneath 6. 1 second later, you're at 37 units. 1 second, follow that up to 36 and go a little above for 37. Estimate a little bit here. 2 seconds later, you're at 53 feet. Follow 2 seconds up to 50. A little beneath 54. 53 feet. 3 seconds later, you're at that same height. 4 seconds later, the ball starts changing directions and dropping, and that would be 4 seconds is 37 feet. Follow 4 seconds up to 37, which is going to be a little above 36. And you should see the symmetry happening. And the output values eventually line up with each other. 5 seconds later, you're back to 5 feet. Again, you should see that symmetry happening here. And then you're going to connect this, not with a ruler and straight lines, but with a U shape, a downward facing U, a parabola. And then now you can see what the graph would look like. If we're asked about the max height would be where that vertex is. And the max height is the highest height of the ball, which is 53 feet, or units in this case. Go by whatever measurement they tell you. And then if we wanted to know the time in which that happens, in this case it's going to be like halfway. The ball stays in that height for a while, so it's going to be the halfway mark, which would be 2.5 seconds.